Hi, I am Dr. Karunamurthy from VIT University Chennai campus. In this lecture, we are going to discuss about solving problems on transportation model. The transportation model involves like transporting materials from one place to another. Assume that if you are going to have supply of the material from various sources, and these materials has to be transported to different destinations, and assume that we are going to have many destinations. So how much quantity we have to transport from each source and to every destination, so that the total transportation cost involved is minimum. So this is what we are going to do in this case. And for solving the problems in transportation model, and the following steps are involved. Initially, to begin with, we have to determine the total demand and total supply for the given problem. And if these two are equal, then we say that problem is balanced demand and supply problem. So this condition should be satisfied initially. Once this condition is satisfied, then we have to determine the initial basic feasible solution for the given problem. To obtain the initial basic feasible solution, three different methods are available, like northwest corner rule, least cost method, then Vogel's approximation method. Among these three methods, Vogel's approximation method is preferred. This is because, compared to other methods, if you get the initial basic feasible solution from Vogel's approximation method, then the number of iterations involved in obtaining the optimality will be minimum. That is why we prefer Vogel's approximation method. Then once we get the initial basic feasible solution, then we have to check for degeneracy. This checking degeneracy is done like this. We have to determine the number of allocations that we have made, and if this number of allocations are equal to m plus n minus 1, then we say that solution is not degenerate. Instead, if the number of allocations is less than this m plus n minus 1, then we say the obtained solution is degenerate solution. Here this m and n are the number of rows and number of columns in the given problem. M refers to number of rows and n refers to number of columns. So normally the solution should not be degenerate. That means the total number of allocations that we are making should be equal to m plus n minus 1. After checking this, once we come to know that the obtained solution is not degenerate, then you have to check the obtained solution is optimum or not. This checking this optimality can be done by two different methods. One we call it as stepping stone method, another one is called Modi method. Modi method is nothing but, in short, we have written here, it is actually modified distribution method. Modified distribution method is referred as Modi method. Then after determining, you are checking the optimality, and if you come to know that the solution that we have obtained is not optimum, then we have to iterate for optimality. When I say we are iterating for optimality, we are trying to arrive a better solution. Then again we have to check the obtained solution is optimum or not. So for that also again we will be using this Modi method. So Modi method is normally used to determine whether the obtained solution is optimum or not. If the solution obtained is not optimum, then we will be iterating to determine the next better solution. So this process is cyclic, and we will be proceeding until we get the optimum solution. Let us solve a problem. So this is a given problem. So in this problem, we have three factories, factory F1, F2, F3, and there are four warehouses, W1, W2, W3 and W4. From these factories, the products that are being produced are they can supply 6 units from factory F1, and from factory F2 they can supply only 1 unit, and factory F3 can supply 10 units. Whereas at these warehouses W1, W2, W3 and W4, the demand over a period of time is given here. For warehouse 1 it is 7 is the demand, and for warehouse 2 it is 5, and for warehouse 3 it is 3, and for warehouse 4 the quantity required, the demand at warehouse 4 is 2. And the cost of transportation from factory 1 to warehouse 1 is given here. For unit transport, the cost that is involved is rupees 2. Similarly, from factory F1 to warehouse 2 it is given as 3. and this complete table gives you the transportation cost for transporting 1 unit of the product from each and every factory to various warehouses are given in this table. So now we are going to determine initially the initial basic feasible solution. Right? Before that, we have to determine what is the total demand and supply. To determine the total demand and supply, it is like we are going to add this. See, total supply is 10 plus 1 plus 6. This is 17. And demand is here 7 plus 5 is 12. 12 plus 3 is 15. 15 plus 2 is 17. So we have a balanced demand and supply. This is the very first step that we have to do. So here you can see the very first step is that we have determined the total demand and total supply, and both the units are equal. Once we come to know that the demand and supply are equal, then we can proceed for determining the initial basic feasible solution. So to determine the initial basic feasible solution, we are going to use Vogel's approximation method. In the Vogel's approximation method, the step is like this. For each and every column, we will be determining penalty, and for every row in this matrix, we have to find the penalty. Penalty, when I say penalty, is like this. Penalty is nothing but the difference between the smallest value in the column and second smallest value. So if you refer in this case for the column number 1, smallest value is 1 and second smallest value is 2. The difference between these two is 1. That is what is written here. Coming to column number 2, smallest value is 0 and second smallest value is 3. Difference is 3. That is written here. Similarly, coming to column number 3, smallest value is 6 and second smallest value is 11, and the difference between these two is 5. That is written here. And for column number 3, smallest value is 1 and second smallest value is 7. The difference is 6. So this we have written for each and every column. Similarly, we have to write for each and every row. There are 3 rows here. So for the first row, second row and third row, we have to determine the difference between smallest and second smallest value. So that if we calculate, and for these rows, row 1, row 2 and row 3, we have determined the penalty. The next step is that among these penalties, which we have determined column wise and row wise, which is the maximum penalty. So this is the maximum penalty. So now we are going to do the allocation for this column. So we should do the allocation for the penalty which is maximum. So the maximum penalty among this is 6. This corresponds to the column number 4. So to make the allocation, now we have to select in this column number 4, which is having the minimum transportation cost. So for in column number 4, if you see here, this is 7, this is 1 and this is 9. So the minimum transportation cost is corresponding to this cell. So this cell is corresponding to factory number 2 and destination is warehouse number 4. So we are going to make the allocation for this cell. So this cell, the demand for this cell is 2 and the supply for this cell is 1. So we have only one quantity that can be supplied to this, and the demand at this warehouse is 4, because this cell corresponds to factory number 2. From factory number 2 we can supply only 1 unit, whereas this cell refers to warehouse number 4 where the demand is 2. So even though the demand is 2 here, but we can supply only 1 quantity. So let us supply 1 quantity here. So now what will happen? The total demand is 2 here. Once you supply quantity 1 to this cell, so the remaining demand will become 1, because already 1 we are supplying. And from here we cannot supply, from this factory we cannot supply any more, because already we are supplying 1. So this is what we are trying to do. So for this cell I am going to allocate 1 unit from this factory. So the remaining demand will be 1. So that if you see here, it is like this. So we are going to make the allocation for this cell. For this cell, the demand is 2, whereas supply is only 1. So if you supply 1 quantity, from here you cannot supply any more. So this will become 0. And here demand is 2, since we have allotted 1. So remaining quantity is only 1. So this supply has become 0. This is referring to factory number F2. So from factory number F2 we cannot further supply anymore. So we are going to delete this complete row. So if you delete this complete row, I am striking out this second row, because we cannot supply anymore. Now this row is not existing, second row is not existing. So when we strike this second row, what will happen is like the penalty whatever we have determined here, that we have to determine once again a new penalty has to be determined, because this second row is being eliminated. So if you want to determine the penalty for this, then here the smallest value is 2 and second smallest is 5, difference is 3. Similarly for this column, so for column wise we have to determine the penalty. So if you determine the penalty column wise, then we will get like this: 3, 5, 4 and 2. These are the difference between the smallest and second smallest for every column. 3 and 5 difference is 3 and 8 difference is 5. 11 and for 11 and 15 difference is 4. So once we write the penalty once again, then now we have written in for each and every column, and here you will not have any difference. So this is already we have determined these penalties, so that we are writing as such. Now these are the penalties: 1, 3, 2, 4, 5 and 3. Among these penalties, which is the maximum penalty, that we have to determine, and that refers to number 5. This is having the maximum penalty. So in this column now we have to determine which is having the minimum transportation cost. So there are two cells, one is 3, other one is 8, because this we have deleted. So among 3 and 8, which is a minimum, 3 is the minimum. So for this cell we are going to do the allocation. So 3 is the minimum value, and corresponding to this 3 we are going to do the allocation. Here the supply is 6 quantities, whereas demand is 5. This is corresponding to factory number F1 and for warehouse number 2. In warehouse number 2 demand is 5, whereas from factory F1 we can supply 6 quantities. So what we will do, since demand is 5, from here we will supply 5 quantities, so that will meet our demand. Once we supply 5 quantities, then this demand is met, so this will become 0. And from this factory still we can supply 1. So we have allotted 5 quantities here. From 6, since we have allotted 5, remaining is 1, and demand is 5, and entire demand is being met. 5 we have supplied, so this has become 0. Now from this, for this warehouse we should not supply anything, because its demand is being met. So since this has become 0, I am going to strike this column, that is your warehouse number 2. So warehouse number 2 we are going to strike out. So once we strike this second column, for corresponding to warehouse number 2, then the penalties here it will change now. Now we have to write the new penalty. Smallest is 2 and second smallest is 5, and difference is going to be smallest is 2, second smallest is 7, difference is going to be 5. So this we are going to write here. For row wise we are going to write the penalty. So now we have written the penalty row wise. So now again we have to compare the penalties which is having the maximum value. This is 5, 4, 2, 4 and 3. Among this 5 is maximum. So allocation should be made to this row. So this we have selected. And here in this cell which is having the minimum value, that we are selecting. 2, 11 and 7 are there. Among these 3, 2 is the minimum value. So for this cell we are going to do the allocation. And corresponding, this cell corresponds to factory F1 and warehouse 1. At this place, warehouse number 1, we can supply quantity 1, and here at this place we can supply quantity 1. So here the demand is 7. So once you supply quantity 1 here, so what will happen? This demand will decrease from 7 to 6, and no more can be supplied from this place. So we are going to allot to this cell we are allotting quantity 1. Once we allot quantity number 1, so this supply becomes 0, and the demand for corresponding to this warehouse is 6 now. Since this is 0, so this row also we are going to delete. Right? Since the supply here is 0, so this is not existing. Now we have only the third row. So we have only one row, and in this row we have the cells which has the transportation cost as 5, 15 and 9. Only these 3 cells are there. So since only one row is there with 3 cells, so what we will do, we will not go for penalty. Instead what we will do is that we will select the cell which has the minimum transportation cost. Among 5, 15 and 9, this cell is having the minimum transportation cost, so we are going to do the allocation here. Here the supply is 10 and demand is 6, so you can supply 6 quantities from here to meet the demand. So now for this we are going to do the allocation. Here demand is 6, supply is 10. So once we supply 6 quantities to this cell, from here the maximum quantity that can be supplied is 10, but demand is only 6, so we are supplying 6. Once we supply 6, this demand will become 0, and from here, since we have supplied 6 quantities, 10 will become 4. Now after allotting this, we have only these two cells. Now you compare these two cells. Among these two cells, which is having the minimum value, this is having the minimum value 9 compared to 15. So for this cell, what is the demand? Demand is 1, whereas supply is 4. So if we supply 1, remaining supply from here will be 3, and here the supply is demand is met. Once this is met, this is the last cell that is available, and for here the demand is 3 and quantity supply is also 3, so we can supply, so it becomes completely 0 and 0 here. So since this problem is a balanced demand and supply, finally we will end up with 0 supply and 0 demand once we make all the allocations. So now the next step is that we have to determine the transportation cost corresponding to this initial basic feasible solution. Transportation cost is determined like this. Here one quantity 1 is allotted to this cell, and the unit transportation cost is 2. So if you multiply this 1 into 2, that is the transportation cost involved in transporting the one quantity from this factory to this warehouse, right? That is from factory F1 to warehouse number 1. And corresponding to this, here if we calculate, then it is 5 into 3. This is the total transportation cost involved. So all this we are going to sum up to get the total transportation cost. This is for the corresponding to the allocation that we have made for the cell number 1, which is corresponding to factory 1 and warehouse 1, and this is corresponding to factory number 1 and warehouse number 2. So 1 into 2, 5 into 3, and other allocations are then we have allocations like 1 into 1, then we have allocation 6 into 5, then 3 into 15, 1 into 9. So that will give you the total transportation cost, and this value whatever we obtained is initial basic feasible solution, which we have obtained using Vogel's approximation method. Now we have to find out whether this obtained solution, this initial basic feasible solution which we have obtained using Vogel's approximation method, is optimum or not. That we have to check. Before we check for the optimality, we have to make sure that this solution is not degenerate. So to make sure that this solution is not degenerate, we should know how many number of allocations we have made. Here the number of allocations made are 1, 2, 3, 4, 5 and 6. There are 6 number of allocations done. And what is the number of rows? Number of rows are, there are 3 number of rows and there are 4 number of columns. So number of allocations made in this problem is 6. Number of rows are 4, number of columns are 3, so m plus n minus 1 is 6. So these two values are equal, so therefore the obtained solution is not degenerate. This step we have to perform. After determining this, then we have to go for determining whether the obtained solution is optimum or not. So we are going to do the test for optimality. We are going to check for optimality. So for this we are going to follow a method called modified distribution method. So in the case of modified distribution method, the following steps are involved. Initially we have to find out the cost matrix for allocated cells. Followed by this we have to apply u plus v. We will come to know once we do this procedure. Then we have to find out the u plus v matrix for unallocated cells. Then we have to find out the cell evaluation matrix. The cell evaluation matrix, the entries in the cell evaluation matrix should be positive. Only then we say that the obtained solution is optimum. If the entries in the cell evaluation matrix are negative, less than 0, then the obtained solution is not optimum. Then we have to iterate towards optimality. So this we will be doing until we get all the entries in the cell evaluation matrix greater than or equal to 0. Okay, so let us start for optimality test. So first step is that we have to write the cost matrix for allocated cell. This cost matrix for allocated cell is like this. See, if you see this table after doing allocation, so this is the allocation that we have made, and this is the cost matrix for transportation. So this value is cost, whereas this is the quantity that is being allotted. So we are going to write the cost matrix for allocated cell. So that refers to this cell is allocated cell, this cell is allocated, whereas this is not allocated, this is not allocated. The cost values that are there in the allocated cells only we are going to write. This is an allocated cell, this is an allocated cell, this is an allocated cell. So only for the allocated cells we are going to write the cost. If you write the cost for the allocated cells, then we will get like this. These are the cost values corresponding to the allocated cells, right? So we will have 1, 2, 3, 4, 5 and 6 allocations we made, and for that allocation we wrote the transportation cost. Now what we are going to do is that we are going to write u plus v. That means here I am going to write u1, here u2, this is u3, here this is v1, v2, v3 and v4, and the value that is present inside this is sum of u and v. Let us say if this is 2, then this is corresponding to u1 plus v1. So similarly we are going to write, and we will assume any one variable value as 0, then we will determine the values of the other variables. It is like this. Here you can see, so this is u1, u2 and u3, this is v1, v2, v3 and v4. Now the values in the matrix is sum of u and v. Let us say for this cell, here we have the value 2. Let us begin with, for any one variable 0, assume that the value of u1 is 0 now. So u1 plus v1 is this value. Sum of u1 plus v1 is 2. The value of u1 is, I am assuming it as 0. If that is the case, then what is the value of v1? It should be 2, because 0 plus 2 is 2. This is 0, this is 3, then what should be this value? It should be 3, because 0 plus 3 will be 3, right? Now this is known. Now here it is written as 5. Sum of u3 and v1 is 5. Already we know the value of v1, which is 2. This is 5 here. Sum is 5. So what should be the value of this? It should be 3. So like this we are going to determine all the values for this u1, u2, u3, v1, v2, v3, v4. All the variables values we are going to determine. Right? So after determining the values of all the variables u1, u2, u3, v1, v2, v3 and v4, now what we are going to do is that we are going to determine the u plus v matrix for unallocated cells. If you see in this matrix, these are all allocated cells and this is unallocated. Wherever we have this dot, this refers to unallocated cells. We are going to write the sum of u plus v for these unallocated cells in this matrix. This dotted I have represented here with a dot. This refers to unallocated cells. So we are going to write u plus v value for this unallocated cell. Let us say for this cell, if you want to write, then it is 0 plus 12. So we will be writing here as 12. Then 0 plus 6. Then that we will be writing it here. So similarly for all unallocated cells, we are going to write the u plus v matrix. To write the u plus v matrix for unallocated cell, then it is like this. Then the next step is that you have to find out the cell evaluation matrix. Cell evaluation matrix is that we have to subtract these values in the u plus v matrix for unallocated cell from the original cost matrix. From the original cost matrix, we are going to subtract this value. That we call it as a cell evaluation matrix. So for example, let us say in the first row, third column, we have 12. In the original cost matrix, first row, third column, we have 11. Right? So this we are going to subtract. So from the original cost matrix, 11 minus 12, so that we will get as minus 1. Similarly, for all the unallocated cells, from the original cost matrix, we are going to subtract this u plus v matrix for unallocated cell. This we call the cell evaluation matrix. Only if all the entries are positive in the cell evaluation matrix, we say that the solution obtained is optimum. If you see this, matrix, we have negative values. That means the obtained solution is not optimum. So we have to iterate towards optimality. The procedure for iterating towards optimality is, so among these entries, which is having the most negative value, that we have to select. here we have -1 and -1 and there is a tie. We can say like we cannot say which is the most negative value. Both are having the same value. Since there is a tie, we can break the tie arbitrarily. That means you can select either this cell or this cell. So now I am going to select, let us say for example I am going to select this. I am breaking the tie arbitrarily. This tie can be broken arbitrarily. So I am arbitrarily breaking the tie and I am going to select this cell, let us say. If you select this cell, then let us to mark this, let us make a tick mark in this cell. So this cell I have made the tick mark. So now what I have done, I have written the allocations which we have made already. I have made the quantity that we have allotted from factory 1 to warehouse 1, factory 1 to warehouse 2. So whatever allocations we have made, that I have written here now, because I am going to change the allocations, because the allocation what we have made is not optimum. In order to make it as optimum, we are going to make some changes. So for that, now I have written the allocation that we have done already, and this is the cell which we have identified earlier as the most negative value. Now from here we have to form a loop. The loop should start from this cell. The condition is that from here you can move in any direction, either right direction or in the left direction, or you can come down. You can go in any direction, but if the cell is allocated, then we have, if the cell is allocated cell, then we have an option of changing the direction. If the cell is not allocated, then we cannot change the direction and you have to proceed further. Let us say we are going to start from the cell which we have marked with a tick mark. Okay, so from here we are going to start. Let us say I am moving in the left direction. I am moving here. So this cell is allotted cell, allocated cell. So either you can change the direction like this or you can go straight. Let us say if you are going to change the direction like this, then this is unallotted, then you cannot change the direction. Then this cell is also unallotted, no allocations is being made. So then what will happen, we cannot change the direction here, then we cannot proceed further. The condition is that we have to form a loop. When I say we have to form a loop, that means from, if you are going to start from here, then you should come back to the same place. If you let us say we are going in the left direction, and if you are since this cell is allocated cell, if you are going to change the direction, then further you cannot proceed, because these are all unallocated cells. So what we will do, let us go straight further. From here I am going still further. So this cell is allocated cell. If it is allocated cell, you can change the direction. So we are changing the direction here, right? So we started from here, we are proceeding like this. This is allocated cell, so we are changing it again. So here this is not allocated, so you cannot change the direction. This cell is allocated, so we are going straight. We are changing the direction and we are going straight. So this cell is unallocated, so we have to go straight. So here this is allocated cell, you can change the direction, that is allowed. So when you change the direction, it comes back to the original position. So we started from here, went like this. So here this allocated cell, you can change the direction. This is allocated cell, you can change the direction. This allocated cell, this you can change the direction. It comes back. So this forms a loop. So this loop has to be made. Once the loop is made, then we are going to start from this cell and we are going to give the sign for this, like positive and negative sign. The place from where we started, that is positive, right? The place from where we have started, so that we have made it as positive. Then subsequently, so this is the place from where we started forming the loop, so this we have marked it as positive. Then wherever you are changing the direction, change the sign also. So here we are changing the direction, so this sign we have changed. Started with positive, so here this became negative. Then again you are changing the direction here, so change the sign. So from negative it has become positive now. Then we are changing the direction again here, from positive this will become negative. Now in this loop, you consider the cells which are being marked negative. So these are the two cells where we have negative value, and in this, among these negative cells that are being marked negative, which is having the minimum value, right? Minimum allocation that we have made. So that we are going to consider. So that is 1 compared to 3, 1 is smaller value. So that we are going to, so that much amount of changes we are going to make now. So right, so 1 we have selected. The cell wherever we have marked positive, to that cell we are going to add this value 1. Wherever we have marked negative, this much quantity we are going to subtract. So what will happen? So now new allocation will be like this. So here you will have 1 allocation, whereas here this will become 0. Here it will become 6 plus 1, so this will become 7. This is 3 minus 1, this will become 2. So the new allocation is this. This is the new allocation. So earlier we were having an allocation here that we have removed because 1 minus 1 is 0. Here we were not having any allocation. Now it has become 1. And here we were having, this is positive, this is negative, this is positive. So earlier we were having 6 allocation. 6 plus 1 is 7. Here earlier we were having 3. So 3 minus 1 is 2. So this is the new allocation we have made, and this we call it as second basic feasible solution. And we don't know whether this obtained second basic feasible solution is optimum or not. So for that we have to do the optimality. Before we proceed for optimality test, let us find out the transportation cost corresponding to this. So transportation cost is like, this is 5 quantity we have allocated here, and the unit transportation cost corresponding to the cell is 3. So 5 into 3, and here it is unit transportation cost is 11 and the quantity allocated is 1. So similarly you multiply all these quantity that are being allocated with the unit transportation cost, you will get the total transportation cost. Now we are going to determine whether this obtained solution is optimum or not. For that we have to apply the modified distribution method, that is MODI method, which involves the procedure like writing the cost matrix for the allocated cell, then applying U plus V, then writing the U plus V matrix for unallocated cell, and determining the cell evaluation matrix. The same procedure we are going to follow now. Now that procedure we are going to adapt for the second basic feasible solution. Right. So for this corresponding to the second basic feasible solution, I have written the cost matrix for the allocated cells. These are the allocated cell. Its cost values from the original matrix I have written here. Then the next step is that you have to apply UV. So this is U1, U2, U3, V1, V2, V3 and V4. Let us begin with, for a particular variable, the value of the variable as 0. So this is 3, this is 0. So what should be this value? This is 3, because 0 plus 3 is this value. And this is 0, this is 11. What should be this value? V3 value. 0 plus 11 is equal to 11. This is 15, this is 11. So what is this value? This should be 4. 4 plus 11 is 15. So like this you determine all the values of these variables, V1, V2, V3, V4 and U1, U2, U3. So because the sum of UV is inside this, so we are finding out the values of U and V. After determining the values of U and V, all the values of U and V, then we are going to write the U plus V matrix for unallocated cell. Unallocated cells are this dotted. Now we are going to write the values for this dotted, and these values, this here for this cell we will write dot again. That means 1 plus 0 I will be writing it here as 1, and 1 plus minus 4, that is minus 3, I will be writing it here. For the unallocated cells I am going to write the U plus V matrix. So this is the U plus V matrix for unallocated cells. This we have written. Then the next step is that cell evaluation matrix. From the original cost matrix we will be subtracting this value. From the original cost matrix we are going to subtract the values that are there in the U plus V matrix for unallocated cell. That we call it as a cell evaluation matrix. So here we have written the cell evaluation matrix. Again for the second basic feasible solution also, the cell evaluation matrix we have a negative value. That means the obtained second basic feasible solution is not optimum. So we have to iterate for optimality. So in the cell evaluation matrix, whichever entry is most negative, that we have selected, right? So now the allocation that we have made in the second basic feasible solution has to be altered, and we have to go for the third basic feasible solution. So for that I am making a tick mark in the cell which has the most negative value in the cell evaluation matrix. This is corresponding to second row, third column. Second row, third column. So second basic feasible solution was like this. These are the allocations we made. So in the second row, third column, I am making a tick mark. So this allocation we are going to change. So to change this, what we have to do? We have to form a loop. To form a loop, the procedure is like, from here we can proceed either up or to the left or to the right or downwards. In any direction we can move. So let us say I am moving in the right side direction, and the condition is that if the cell is allocated, we can change the direction. We have to form a loop in such a way that we have to start from the place which we have marked with a tick mark. So we are starting from here, and subsequently when we proceed in any direction, if the cell is allocated, then you can change the direction, and if the cell is not allocated, you have to go straight. Let us say, instead of going right, assume that from the cell where we have marked this tick mark, assume that I am going to proceed in the left direction. If you proceed in the left direction, this cell is not allocated, so you cannot change the direction. This cell is not allocated, so we cannot change the direction, and further we cannot proceed, so it stops. This is not forming a loop, so you should not consider this. So now let us say if I am proceeding in the upward direction, if you proceed here, this is allocated, so you can change the direction. Let us say if you are going here unallocated, you can't change the direction, so it is not going further, so that is also not possible. So let us say I am moving in the upward direction, this is allocated, so we can go like this, and this allocated. If you want, you can change the direction, or you can go straight. Let us say if you are going to change the direction, then what will happen? Let us say if you are going to change the direction from 5 further, if you are going to proceed, say let us say we have started from here, gone here, this allocated cell, then we are proceeding like this, then here this is unallocated, so we cannot change the direction. Okay, so the other possibility, we are trying all possibilities, right? So now let us proceed in the right direction from the cell where we have marked the tick mark. Okay, if you proceed in the right side direction, then it will be like this. So I am moving in the right side direction. This is allocated cell, I can change the direction. This allocated cell, I can change the direction. This allocated cell, I can change the direction. It comes back to the starting position. We started from here, and it has come back to the starting position itself, right? The ending and starting are the same place, so it forms a loop. So now what we have to do, we have started from here, so you mark this as positive. We are changing the direction, so change the sign. This is negative now. Then here you are changing the direction, so change the sign. This is from negative, it will become positive. Again you are changing the direction here, from positive it will become negative. So we made this positive negative for the cells wherever we are changing in the direction. Now we have to select the cell wherever we have marked negative value, these two cells. Among these two cells, which is having the minimum value, this is having the minimum value. So that value we are going to add if the cell is marked with positive sign, and we are going to subtract if that cell is marked with negative sign. Right, 1 we have selected. So now what will happen, new allocation will be in the third basic feasible solution. The new allocation, here you will have 1, this allocation will become 0, this will become 2, and this will become 1. Right, so this is the new set of allocation which we have made. This is the third basic feasible solution. Now we don't know whether this obtained third basic feasible solution is optimum or not. So to determine the optimality, what we have to do, we have to apply modified distribution method, that is MODI method. So for that we have to do this U plus V procedure we have to follow. Right. So the first step is that we have to write the cost matrix for the allocated cells. So for this allocated cells from the original matrix, I will be writing the cost values. Then we will apply UV. If you write the cost value for the allocated cells, then these are the cost values corresponding to the allocated cells, and we are going to determine, we are going to apply U and V. So the sum of UV is represented in the particular cell, right? And we'll to begin with, we'll make the value of one variable as 0. Let us say u1 is 0 here, so this is 0, this is 3, so this should be 3. This is 0, this is 11, so this should be 11, because 0 plus 11 u plus v equal to this is 11, right? So now we determine all the values of the variables u1, u2, u3, v1, v2, v3 and v4. After determining this, now we will write the u plus v value for unallocated cells. And so these are the unallocated cells. So for these values we are going to cells we are going to write the values, that is u plus v we are going to write. So once we write the u plus v matrix for the unallocated cell, then we have to subtract from the original cost matrix this value. That will give you the cell evaluation matrix. From the original cost matrix, when you subtract, so this is the cell evaluation matrix which we have obtained after subtracting the u plus v matrix for the unallocated cell from the original cost matrix. And in this cell evaluation matrix, we found that all the entries in the cell evaluation matrix are greater than or equal to 0. We don't have any negative value here. All the values are greater than or equal to 0. Since all the values in this cell evaluation matrix are greater than or equal to 0, the obtained solution, that is the third basic feasible solution, is optimum. So this indicates this is the final solution and we have obtained the optimality. This is because all the entries in this matrix are greater than or equal to 0.